All right, so this is a quick video on direct variation. We have our goal and our essential question. So direct variation determines whether or not the following tables are proportional. Another word for direct variation is the word proportional. So that's very important that we understand that when you see the word direct variation, that you know that basically means that this is proportional. So using the information that we learned yesterday about being proportional, if we have a table, we can do cross products to see if they're proportional. So I can do 8 times 2 and get 16, and I can do 16 times 1 and also get 16. That is one way that I can tell that that table is proportional. Another way I can tell that this one is proportional, and this is not always the case, but if you notice on that table that they have an ordered pair of 0, 0. And remember from the yesterday's lesson that if the graph goes through the origin, that it is proportional. So that is another way that I could tell that this one is proportional. The second table, again, we can do cross products. 3 times 10 is 30. And 15 times 2 is also 30. So I can tell that both of these are proportional. Since they're both proportional, we can use what's considered the direct variation formula, which is on your formula chart. And when we do the direct variation formula, the formula says that y equals kx. And k is representative of what's called the constant of proportionality. And that's another fancy word for slope. Now, they don't call it slope because when it is proportional, it has a different word, and that word is constant of proportionality. But it basically is the same thing. So we can find the slope of a line by either finding your order pairs and finding the differences. So from 8 to 16, we know that we went up 8. And from 1 to 2, we went up 1. So my slope is 8, which is also considered, again, constant proportionality. So my formula would be y equals 8x. On the second table, again, we know it's proportional, so it's going to have a k, which is constant proportionality. We do the same thing and find the slope. So from 10 to 15, that is an adding of 5. And from 2 to 3, that is an adding of 1. So that means my slope was 5, or my constant of proportionality is 5. So I have my equation as y equals 5x. All right, again, our direct variation formula is y equals kx, where k is the constant of proportionality. What would you do to find the constant of proportionality? So you can use this triangle here to see how to find k. And the formula to find k is basically you would take the formula they gave and remember, if it's like slope, instead of doing y2, so I'm going to write this up here. Slope is y2 minus y1 over x2 minus x1. And instead, we're just going to take 1y and 1x. So we're just going to divide a y by an x. We don't need 2, we only need 1 because it's a constant of proportionality. So it's just a little bit different in that way. So I'll have a key already posted with the organizer to help you with direct variation. So this is some of the information that can help you. You can pause that and take a look at it on things like the formula, definition is proportional, the ratios are constant, which we learned about yesterday. Some of the characteristics like going through the origin. This does not have a constant that we have it going through the origin. And non-examples would be, for example, that I don't have going through the origin and I do have an add-on. So we talked about that a little bit yesterday, so hopefully that will help. So direct variation, the formula is y equals kx. Excuse me, that's on the next line. All right, direct variation means proportional. The formula is y equals kx. And again, the formula for k, or the constant of proportionality, is y over x. So again, it's not y2 minus y1, it's just y. So we have identify the constant of proportionality if possible. Well, you first have to make sure that it is proportional, so there's no add-on. So we already know that my k is 1/2 because it's the one number connected to the x, so that's called a coefficient. If we notice here, we have an add-on. So if we have an add-on, is that going to have a constant proportionality? The answer is no. Because there's a constant because there's an add-on, that means this is considered the slope, not the constant proportionality. So we're going to look here. There's no add-on, which means the number next to the x, the coefficient, which is -7, is going to be my constant of proportionality. So it is always the number next to x. It's called the coefficient. That it would be considered your constant proportionality as long as there is no add-on in the formula. Okay, so we're going to check to see if this are proportional. So we're going to do cross products. So -3 times 4.5 is -13.5. And we're going to do 2.25 times -6, and we get -13.5. So is this proportional? Yes, it's proportional because those two numbers are the same. So if it's proportional, that means I can have a k, which is the constant of proportionality. And to find that, remember, it's y over x. So you can pick any y and put it over x. Well, these numbers are whole numbers, so we're going to use that. So my y is -3 and my x is 4. So that's my answer. So again, we're going to do cross products. -9 times 9 is -81. 13.5 times -6 is also -81. So is it proportional? Yes. And if it's proportional, remember, we can just use y over x. So pick any y you'd like and put it over the x. So I'm going to pick the ordered pair here because they're whole numbers. So I'm going to do 9, which is the y, over -6, which is the x, but that simplifies to 3 over -2. And that would be my constant of proportionality. And last but not least, we're going to see if these are proportional. 2 times 5 is 10, and 20 times 1 is 20. So is that proportional? The answer is no. If it's not proportional, it will not have a constant of proportionality. So we will put a slash through it. All right, question, if it determine if the graph varies directly. If so, what is the constant of proportionality? So we're going to look that is going through the origin, which means yes. So I can take an ordered pair. I'm going to pick this ordered pair, and this is at an ordered pair of 2, 1. So remember, that's your x. This is your y. So remember, constant proportionality is y over x. So my constant proportionality is 1/2. We're looking at this problem here. And we're looking, does that hit the origin? So the answer is no. So no, the graph does not vary directly. So I do not have a constant of proportionality. Okay, so next one, it says assume that we have direct variation. That's what y varies directly with x means. So using y equals kx, write the equation for the following. So we're going to first find k. So to find k, you're going to do y over x. Okay, so this one is 15 over 5, and 15 over 5 is equal to 3. So that's k. So we're going to input that into the formula of k. So y equals 3x. Next one, we have y, which is 4, over x, which is 12. That simplifies to 1/3. That's k. So we're going to put it into the formula. Y equals 1/3 x. Okay, remember this is x and y. So we got 30, which is y, over x, which is 3. That simplifies to 10. So we get y equals 10x. Again, this is my x and this is my y. So k is y over x. I think it skipped. Y over x, so x was 28, so that simplifies to 1/7. So my formula is y equals 1/7 x. Okay, so we're just inputting the k, and again, k is y over x. And next part, if x varies directly as y, x is 12 when y is 27, what is x when y is 3? So we're going to set it up as proportion. So we're going to do y over x, so we have 27 over 12 equals 3 over what is x, which is what we're going to find. So we can use what we learned yesterday about cross multiplying. So we can multiply diagonally. 27 times x is 27x. And 12 times 3 is 36. So we can divide both numbers, both sides of the equation, by 27. So x will equal 36 divided by 27, which is 1.3 repeating. If you simplify this, that's another option. Either answer will be fine. Okay, so let's try another one. So we have, it varies directly, so that means it's proportional. So we're going to do y of 8 over x of 4.5 equals y, we don't know, over x, which they gave us 16. Again, we are going to go ahead and multiply diagonally, cross multiply. That gives me 4.5y, and 8 times 16 is 128. We're going to divide both sides by 4.5 to isolate our variable. This is a one-step equation. And that gives me y equals 28.4 repeating. All right, and then you'll have a Google form to complete for your homework assignment.